The homework on the sampling distribution is due Sunday at midnight, and we talked about the first couple of problems in class on Thursday. But problem 7 is a little bit different in that it doesn't talk about the sampling distribution for the sample mean, but it talks about the sample proportion. And sample proportions happen when you have categorical variables. So remember, a categorical variable, an example of that would be like, oh, I don't know, what county do you live in? That's not numerical. That's a category that I could put you in. Or what type of shoe are you wearing? Are you wearing Nike, Adidas? Are you wearing a dress shoe? What kind of shoe are you wearing would be a categorical variable. So far with sampling distributions, we only talked about sample means. But in this case, we have a sample proportion because our data is categorical. Take a look at number 7. Number 7, for my homework, yours will be a little bit different, but pretty much the same. It says, about 77% of all female heart transplant patients will survive for at least 3 years. 60 female heart transplant patients are randomly selected. What's the probability that the sample proportion, so there's kind of my first clue that it's not a sample mean, but it's a sample proportion, surviving for at least 3 years will be less than 73%. So when they collect the data, the information that they want is they want to know if the individual has survived or not. So what kind of data is that? If I ask the individual, have you survived or not, the answer will either be yes or no, right? And so that is categorical data. They give us the population proportion. The population proportion is 77%. So here is my population of all individuals that have a heart transplant. There they are. They're in my population. The population proportion of individuals that survive at least 3 years after the heart transplant is notated with P. P is the population proportion. The population proportion is 77%. You can see it there, right? 77% survive at least 3 years. That's the population proportion. And then they take a sample. How big is your sample? They say 60 female heart transplant patients are collected. So my sample size is 60. And of those 60, they want to know the probability that the proportion of those 60 who survive at least 3 years will be less than 73%. So they want to know the probability that the sample proportion, how we notate the sample proportion is with p hat, will be less than 73%. You can see it there. It will be less than 73%. Okay, so one of the things that we didn't talk about with proportions is how do we find the mean of sample proportions? That's the same as the population proportion. Okay, well, what's the population proportion? The population proportion was 77% or 0.77. So we got the mean of the sampling distribution. Now, what's the standard deviation of the sampling distribution? What we do is we take the square root of P. Notice when I said P, I meant the population proportion, right? Times 1 minus P, and then divide that by the square root of n. So let's see if we can figure that out. The square root of the population proportion times 1 minus the population proportion, and then we'll divide that by, in this case, my n value is 60. All right, so I will go ahead and crank through that calculation. And get my calculator here. So hopefully you can see what I'm about to do. We got the square root, because you got to turn on first, square root of, here comes the top. Well, maybe to get the top, I should put the top in parentheses. So the first set of parentheses starts the square root. The second parentheses starts the top. So here we go. We got 0.77 times 1 minus 0.77. maybe I can do that in my head. 1 minus 0.77, that would be what? 0.23, I believe. You can double check that, but I think that's right. In the top, so that finishes up the top. What's 0.233? I just kind of did that in my head. 1 minus 0.77 is 0.23. Divide that by 60. Now, in the square root, so all of that's under the square root. Let's figure out what that is. That is 0.0543. Okay, so that's the standard deviation of the sampling distribution. All possible samples of the survival rates of these heart transplant patients. All right, so I got my mean, I got my standard deviation of the sampling distribution. That's sometimes called the standard error. So I'm ready to go, right? Mean, standard error, and now I can find my probability. Remember, I want the probability that my sample proportion is less than 0.73. All right, let's do it. Now we should be able to go to StatCrunch. Let's go to StatCrunch now. StatCrunch. Go to the normal calculator. In the normal calculator, I'll put in my sampling distribution, calculator, normal. I'll put in my sampling distribution mean, which was 0.77. It's the same as the population proportion. The standard deviation of the sampling distribution, 0.73. No, sorry, that wasn't right. What was it? It was this thing, right? 0.0543. 0.0543. And they want to know the probability that the sample proportion is less than 0.73. All right. Less than 0.73. And I'll give it to you. I'm guessing they want 4 decimal places there. I'll remember to round that up to a 7, but I'm going to copy and then paste it. Round to 4 decimal places. Okay. I'll remember to round that up to a 7. Should do it. Okay. All right. Hope that helps. We'll talk more about that on Tuesday, but hopefully that will at least get you through.